Let us get an overview of what we will learn today. Welcome to Time Series Fundamentals, Trend, Seasonality, Cyclicity, and Noise. In this lesson, we will learn what time series data is and explore its key patterns like trend, seasonality, cyclicity, and noise. We will use real-world data like climate records and sales figures. Do not worry if you are brand new to Python, follow along, try the examples, and you will get the hang of it quickly. Let us start our journey together. Running the cell now. Take a second to think of things you notice that change over time, like temperature, sales, or your daily steps. Let us get started by preparing Python to suppress distracting warnings and say hello. We are writing a comment to explain this cell. We import the warnings module, which helps us control warning messages. Now we turn off these warnings so our notebook is clean. This prints a friendly greeting to let you know the script is running. Running the cell now. Try writing your own greeting in the print statement next. Let us briefly talk about what time series data means. What is time series data? Time series data simply means measurements taken over time. Examples: daily temperatures, monthly sales, or the number of website visitors each hour. Patterns can often be found in this data, and we can use Python to help us spot them. Running the cell now. Think of one thing in your life you could record over time. Now, we will load a real climate dataset of daily minimum temperatures so we can see patterns directly. The comment explains this block will load a real dataset of temperatures. We import pandas, a powerful Python tool for working with data tables. This variable stores a link to our data, which is a CSV file on the internet. We use pandas to read the CSV file and save it as a table called data. This prints out how many rows and columns our data has. Let us print a header to show the next output is the first few rows. This displays the first 5 rows of our dataset so we can see what it looks like. Running the cell now. Can you describe what each column might mean in this table? Let us see what the temperature data looks like visually with a line plot. We add a comment to show we are going to make a basic plot. This imports a plotting library called matplotlib, which makes charts. We set the size of our chart to make it easier to see. This draws a line chart using the temperature values. We add a title to tell viewers what the chart shows. Labeling the horizontal axis makes it clear that each point is a day. The vertical axis shows the temperature in degrees Celsius. Grid lines are added to help read the chart values. Finally, we display the chart so we can view it. Running the cell now. What changes do you notice in this plot? Does it look regular or random? Next, let us talk about what a trend looks like in time series data. Spotting trend in the data. A trend is a long-term increase or decrease in the data over time. It is like noticing that winters are getting warmer every year. Let us check for trend in our temperature data. Running the cell now. Look for parts of the line that move mostly up or mostly down. Let us find the trend by averaging temperatures over each year and plotting that line. This smooths out the ups and downs so trends are easier to spot. We add a comment to explain we are measuring the trend. This makes a new column in our data with the average temperature for each set of 365 days. That is called a rolling mean. Here, we make a new chart. The original daily temperatures are plotted in blue as before. Now, we add the red trend line, showing the yearly average. We add a title so everyone knows this chart shows a trend. A legend helps us tell which line is which. The chart appears so we can compare the daily temperatures and their trend. Running the cell now. Can you see if the trend is mostly flat or changing over the years? Let us introduce seasonality, which repeats on a regular basis. What is seasonality? Seasonality means patterns that repeat at regular times, like warmer summers and colder winters. This happens again and again, like the changing seasons each year. Let us hunt for seasonality in our temperature data next. Running the cell now. Imagine other seasonal patterns you know. Can you think of 3? We will show how temperature changes during each month. We take the average for every month, making seasonality easy to spot. We write a comment for this cell about finding seasonality. This adds a column to show which month each day belongs to. Now, we group by month to calculate the average temperature for each month. Let us prepare a bar chart. Each bar shows the average for that month. Title tells us what the chart is about. The horizontal axis indicates the month from January to December. We show the average temperature for each month on the vertical axis. The chart pops up. Look for warm and cool months. Running the cell now. What months are warmest or coldest? Is the pattern what you expected? Now we will talk about cycles, which are like wavy patterns that do not repeat at set times. Cyclic patterns in time series. Cyclic patterns are up and down waves that do not happen on a regular schedule. Unlike seasonality, cycles could last a few years and are not tied to the calendar. Think of things like economic booms and busts happening at uncertain intervals. Let us see how to spot cycles. Running the cell now. Try to imagine something in your life that goes up and down, but not always at the same time each year. Let us try a larger average, over about 2 years, to see if any slow waves or cycles appear. This comment says we are hunting for cycles using a bigger smoothing window. We create a new column using a 2-year rolling average, hoping cycles show up. We set up a chart as before. The daily temperatures are faded so the cycle stands out more. The purple line is our cyclic line, drawn from the 2-year averages. Title points out we are looking for cycles in temperature. Legend explains which line shows what. The chart displays so we can look for slow, long-term ups and downs. Running the cell now. Does the purple line swing slowly up and down? How is it different from the seasonality? Let us talk about noise, which is all the little random changes and surprises in the data. What is noise? Noise is the randomness or unexpected bumps in the data. It is like static on a radio, it makes real patterns harder to see. We will see how to spot and understand noise. Running the cell now. Look back at the first plot and notice all the little spikes. Those are noise. Let us try removing the trend from our data. What is left over is mostly noise. This helps us focus on the irregular bumps we cannot easily explain. Comment explains we are looking at noisy parts by removing the smooth trend. We subtract the trend from the original data to find the noisy leftovers. Set chart size as before. We plot the noisy data in gray to see it clearly. A title tells us we are now looking at mostly noise. Horizontal axis is still the days. Vertical axis is labeled noise to show what we see. Chart appears. Are the bumps more obvious now? Running the cell now. What do you think is harder, seeing trend or seeing noise? Let us see how Python handles mistakes like asking for a column that does not exist. This teaches us safe ways to explore new data. This comment says we will check what happens if we ask for missing data. The try statement means Python will try to do the code inside. We look for a column that is not in our data. If Python cannot find that column, it jumps to the except part. Now, we print out a helpful message if we had a mistake. Running the cell now. Make a typo in a column name and see the error, then fix it. Let us add a column to flag days colder than 5 degrees Celsius. This shows how to make new columns by applying conditions. Comment describes we are creating an extra column to flag cold days. We add a column that is true when the temperature is below 5, otherwise false. We print the date, temperature, and our new column to see the result. Running the cell now. Try changing the temperature cutoff and see which days are different. Sometimes we accidentally add or load columns we do not need. Let us see how to remove them, but only if they exist to avoid errors. Comment says we are cleaning up columns in our data. We check if the unwanted column is in the data. If not, nothing happens. If it is there, we drop or remove that column. Finally, we print out the list of current columns left in our table. Running the cell now. Use this pattern to safely clean up your data before analysis. Now, let us find out how many days in our data were considered cold. Summing true values counts them up for us. The comment shows we are answering a real question using our data, how many cold days. We sum true values in the cold day column. Python treats them as ones. Prints the total number of cold days in an easy-to-read message. Running the cell now. Change the rule for cold days to something else and see what changes. Let us use a loop to look through our data and print the first 5 cold days. Loops help us repeat actions, like searching for patterns. Our comment says we are setting up a simple loop to print some results. We track how many cold days we have printed so far. For each row in our data table, we get both its number and its content. We check if the day is marked as cold. If yes, we print the date and temperature for that cold day. Count goes up since we found a cold day. If we have found 5, we stop the loop early. Running the cell now. Loops like this are super useful for searching and summarizing lists of information. We can use a Python shortcut called a list comprehension to find years with many cold days. This lets us make lists based on conditions, quickly. This comment says we are using a list comprehension to solve a real-world question. We add a column for the year using our date. Get the list of years in our table. Make a list of years where there were more than 60 cold days. Print the years that meet our rule. Running the cell now. Try other cutoffs to find which years were extra warm or cold. Let us sort our data to find the hottest days on record. Sorting lets us quickly pick top or bottom values. A comment to explain we will sort and show the hottest days. We sort by temperature, from highest to lowest, and take only the first 5 rows. Prints the date and temperature for these hottest days. Running the cell now. Try sorting for coldest instead, or print more than 5. Filtering helps us focus only on the part of the data we want, such as summer months. Now we will see some summer temperatures. The comment shows we are selecting only the summer months in Australia. We make a new table with only December, January, or February data. Printing a few summer days, let us spot what temperatures were recorded. Running the cell now. Switch months and check other seasons. Do you notice any patterns? Often, we want to combine data slices to compare conditions. Let us see the average temperature in summer versus winter months. This comment says we are making a comparison between 2 slices of time. We pick winter months, just like we did summer. We ask for the average summer temperature. The average winter temperature is found the same way. Now, we print both numbers so they are easy to compare. Running the cell now. Compare these averages to what you expected. Is the difference big? Let us make a mini project that takes your input for a temperature cutoff and tells you how many days were below that value. We label this as a mini project with user input. This line asks you to type in a temperature to use as the cutoff. We turn your answer into a number for calculations. We select all days in our data that were below your cutoff. This now prints how many days matched your rule. Running the cell now. Try several cutoffs and see how the counts change each time. Now, let us visualize the days you picked as extra cold on the chart. Comment says this is part 2 of our mini project. Now we will plot the days found. Set the chart size for clear viewing. Plot all temperature values first. Highlight days below your chosen cutoff in red dots. Draw a horizontal red line at your cutoff as a visual guide. Title makes clear what chart we are looking at. Legend helps keep track of what the marks mean. Chart pops up to show how those days stand out. Running the cell now. Are those cold days grouped together, or do they pop up everywhere? Let us talk about some smart habits to use every time you work with time series data. Best practices for time series analysis. Always plot before you analyze. Pictures reveal hidden details. Check for missing data and odd values. Try different window sizes for rolling averages to spot both short and long patterns. Document your steps with comments so others can learn from you. Running the cell now. Pick one tip here and try it on your next dataset. Missing data can ruin analysis if we ignore it. Let us check for missing values and fill them if they exist. Comment reminds us this cell is for troubleshooting missing data. We count any missing values in our main temperature column. Print number of missing spots found. If any are missing, we take action next. Here, we fill in any missing spots with the overall average temperature. Let us print a message to confirm what we did. Running the cell now. Try forcing a value to missing and rerun this cell to test. Here is a fast way to check which columns in a table are numbers. This helps when deciding what can be plotted or averaged. Comment explains we are finding out which columns contain numeric data. This line gives a list of columns that have numbers in them. Printed output lets us check and plan our analysis. Running the cell now. Use this trick for big tables with lots of different types of data. Ready for a challenge? Let us ask you to pick a month and find out how many days in that month were warm. The comment reminds us this is a user challenge cell. We ask for a month number between 1 and 12. We turn your answer into a number. Pick out all the rows belonging to your chosen month. From those, we only keep days warmer than 20. Printing the count for your chosen month makes the answer clear. Running the cell now. Try different months and see which are warmest, then repeat for a friend. If you enjoyed this, like and subscribe for more beginner Python lessons. Before we finish, let us recap what you have learned so far. Quick review. In this lesson, you learned what time series data is, how to spot trend, seasonality, cycles, and noise, how to work with real datasets using Python, how to visualize and analyze patterns in data. You are now ready to explore your own time series. Running the cell now. Write down one thing you learned and teach it to someone else. Let us wrap up and encourage you to keep learning and practicing. Thank you. What next? Thank you for joining this Beginner Time series lesson. Subscribe to the channel for more Python and data science tutorials. Try these ideas on your own data and share your results. Happy coding! Running the cell now.